Hello everyone. Now we will discuss about electric circuits. An electric circuit is an interconnection of electric elements. So this is a complete electric circuit or a complete loop where we have a battery power source and a load which is a lamp. So when we connect the battery and the lamp through wires, then a current flows in that circuit. So this is an example of a complete electric circuit with the source, load, and connecting equipment or transmission equipment. Um, Now talking about the system of units that we measure quantities in terms of units. For example, if we have length, then it's a basic unit. These are the basic quantities. There are two types of quantities: basic quantities and derived quantities. So basic quantities are basic in a sense that they are not derived from anyone, and the derived quantities are derived from a combination of these basic units. So uh, some uh, these are the basic quantities like length. Its basic unit is meter, and its symbol is m. For mass we have kilogram, kg. For time we have second, and then we have electric current and thermodynamic temperature we have Kelvin, and luminous intensity we have the candela. Now we will talk about system international prefixes that for larger quantities and smaller quantities we mention them in terms of standard form. So uh, these are certain prefixes like for giga means 10 raised to the power 9, for mega will means 10 raised to the power 6, for kilo will means 10 raised to the power 3. Similarly milli, micro, nano and pico, and these are their symbols. Now, electric charge. Electric charge, it is the property of matter. It is measured in coulombs, and 1 coulomb of charge requires 6.24 into 10 raised to the power 18 electrons. There is a law of conservation of charge which states that charge can be moved but it cannot be created or destroyed. And now talking about electric current is simply the flow of charge. It is measured in amperes. 1 ampere is equal to 1 coulomb per second. And there are two types of current: direct current, which remains constant, it's unidirectional, and alternating current, which varies sinusoidally with time. So we have the equation of the current is I is equal to dq by dt, which means that current is equal to rate of change of charge. Electric current is the flow of electricity, much like the flow of water in a pipe. It is measured in ampere as opposed to gallons per minute of water. Now we have three types of material category. First of all, the conductors, which conduct free electrons easily. These are easily directed, and these are usually metals, which means copper, aluminium, gold, and platinum. Then we come across semiconductors, which are dielectrics. Um, they have four valence electrons. They polarize with some electron flow due to the electric fields. These are in between the conductors and insulators. And then we have the insulators, which do not conduct at all. No free electrons, no current flow with the field. Why does the current flow? A voltage source provides the energy required to produce a current. So we need a voltage source. Volts is equal to joules per coulomb, or it is also defined as the work done on the charge, dW over dq. A source takes charged particles, usually electrons, and raises their potential. So they flow out of one terminal into and through a transducer on their way back to the source terminal. Voltage is a measure of the potential energy that causes a current to flow through a transducer in a circuit. Voltage is always measured as a difference with respect to an arbitrary common point called the prompt. Voltage is also known as electromotive force or EMF outside the engineering. It can also be explained as a pressure. Voltage is the electrical pressure in the system, much like the water pressure. Electrical pressure is measured in volts as opposed to pounds per square inches. Voltage across a circuit element is the energy absorbed or expended as a unit charge moves through the element. It is analogous to the pressure. It is sometimes called the pressure difference, which causes the flow of current. V is equal to dW by dQ, that is the work done on the charge to move it. And now this is the resistance. Resistance is simply the restriction in the flow of current, and smaller wires, conductors and poor conductors have high resistance, and its formula is R is equal to rho L over A. It is directly proportional to the length and inversely proportional to the area. It is basically the restriction in the flow of current. So here we have Ohm's law, which is a very famous law between the relationship of current, voltage and resistance. We have current is equal to voltage over resistance, V over R.